friends, welcome to my channel. I hope everyone is doing good. Today we are going to solve a very recent and interesting Leetcode coding problem 3638 maximum balance shipments. So this is a medium complexity coding problem. This is an array related coding question. It's very recent on Leetcode. So I would like to explain with some examples the logic as well as the solution to solve this coding problem. I created some awesome examples so that you can clearly understand this problem. If you are new to this channel, please subscribe to this channel now. It really helps and supports this channel. Here we create videos to help others in their Java and coding interviews. So let's start. You are given an integer array weight of length n representing the weights of n parcels arranged in a straight line. A shipment is defined as a contiguous subarray of parcels. A shipment is considered balanced if the weight of the last parcel is strictly less than the maximum weight among all parcels in that shipment. Select a set of non-overlapping contiguous balance shipments such that each parcel appears in at most one shipment. Parcels may remain unshipped. Return the maximum possible number of balance shipments that can be formed. Okay, so this is what the problem statement says. So in the given array, each number is basically a parcel there, right? And we have to create shipments, but the important thing is maximum possible shipments we want to create, right? Maximum. Okay, so let's take a look at the constant. The n, which is numbers in the given array, will be between 2 to 10 raised to 5, so it can be a very large array. So we have to come up with a efficient solution, and the weight of the parcel will range between 1 to 10 raised to 9 inclusive. So let's take some examples so that you will understand what they are saying. So before we go to the example, I would like to just tell you that it's a like non-overlapping contiguous balance shipments. That's what we are interested in, right? So for example, this is so here you will see that there are 7 parcels given. So this is example 1 we are looking at. So there are 7 parcels given and we want to find out maximum balanced shipment, right? So what is a balance shipment? So for example, let us consider one example so that it will be clear for you. So I have 10 here, let's say, and I have 20 here, and let's say I have 2 here, right? So if I'm looking at these numbers, is it a balance shipment? Yes, it is a balance shipment. Why? Because the last number here is smaller than the maximum number. The maximum number here is 20, right? And it should have at least 2 packages, right? So you will see the definition here. A shipment is defined as a contiguous subarray. Shipment is considered balance if weight of last parcel is strictly less than maximum weight among all parcels in that shipment, right? So this is the definition. So you can see that this is one of the valid parcel, right? Valid shipment. Okay. So what if I put a 24 here? Then will it be valid? No, this will not be valid because 24 is not smaller than the maximum number, right? The maximum number itself is 24. The last number cannot be maximum number basically. If you look at their definition of a valid shipment, right? Balance shipment, I mean to say balance shipment, if weight of last parcel should be strictly less than the maximum weight among all parcels, right? So the maximum weight among all these parcels is 24 and last shipment is 24. It means that it cannot be a balanced shipment, right? So this is what the problem statement says. So I hope you understanding this. But if it is 2, then the maximum is, this one is not maximum, maximum is occurring here, so this can be a balance shipment, right? So this is what we have to find out. So select a set of non-overlapping contiguous balance shipments such that each parcel appears at most one shipment. Parcels may remain unshipped, right? So so when you look at this word maximum, right, maximum possible number, then when you will get maximum possible number, it means that this is kind of a greedy problem basically. Maximum or minimum, you can think this as a greedy problem. So what we can do basically is first we will just look into this first example and identify what can be the maximum balance shipment. So this is a balance shipment, right? You can see that this is a balance shipment because 5 is maximum, 1 is the last one, it is not maximum, right? And we want to maximize it. Okay, So 6 and 4 can be another valid shipment here. Why it is valid shipment? Because 6 is maximum in them and 4 is the last one, right? Okay, and 3 2 is another valid shipment. Why? Because 3 is maximum here and 2 is the last one, right? So there are 3 valid shipments that we can find, or balance shipment we can find. Okay, so we identified that 3 are the one here in this case. What about the second one, this second example, right? So here you will see that if you want to find out a balanced shipment here, then balance shipment can be this one, right? This can be a balance shipment. Okay, why? Because you will see that the maximum here is 20 and the 4 is the last one in here, and it should not be the maximum, so it's not maximum, right? Correct. Okay, so now that is one of them. The second one we can identify is this one, right? This can be a second shipment. Why? Because 10 is maximum here, last one is 1, which it is not maximum, right? So maximum we can find out here is 2. Okay, so now we visually solve this problem. How can we solve this problem in a programmatic way? So as we said, this is we can think of this problem as a greedy problem. So how we can approach this problem? So we will keep track of the maximum we have seen so far, right? And then we will keep track of maximum we have seen so far, and whenever we identify a shipment which is less than that maximum, then at that time we will split that array. Split in the sense is we will make that as a one shipment with those packages. For example, when I start going in the beginning, maximum I can put minus infinity, right? Minus infinity, which is integer dot mean value. You can just say integer dot mean value. Okay, so I am at 2, so maximum is becoming 2. Okay, maximum is becoming 2, and this is not my last number, right? So I mean it's not less than the last number basically, right? So if I go to 5, my maximum will become 5, and 5 is not less than 5, right? Because the last package should be less than the maximum, right? So that is the idea. So when I go to 1, now my maximum is more than 1, right? So you are getting me, right? This maximum value that I saw is more than 1. It means that I can now split this one as a one shipment. This is a valid shipment I am finding, correct? Because it means that my last number is not maximum. I already saw some maximum which is more than my last number basically, correct? So I identified this as one shipment, and once I identify this as a one shipment, what I will do, I will reset my max value again to the um, basically minus infinity, right? For example, minus infinity, and then what I will do, I am going to start from this index next time, right? So my index is 2 here. So what I will do, I will start with a next shipment from index 3. So I will say start is equal to 3, correct? So I will maintain one start variable. I'll write down here, right? So start variable, so it is starting point for the next shipment. Okay, start variable, and I will just update it to 3. So I am going to start next shipment at 3. So I will again start next shipment. So 6, I will update my max to 6, right? And since 6 is the last number here, but not more than 6, so I have to keep going, right? So I will keep going to the next one. 4, 4 is more than the 6 that I have seen, correct? And it means that I can now make this as a one shipment, correct? Because 4 is the next number and I already have 6 here. It means that I have gotten another shipment. So I will increment my count to 2, right? I will create one count variable, right? Count, it's very difficult to write here, so try to be patient. So count is 0 in the beginning, then we found 2 now, right? So count became 2. So now I found 2 valid shipments. Okay, now the third one. Okay, so the third one is I will reset this again, my max value to minus infinity, right? And then my start value to the index 5, right? Index 5. So it means that I am going to start my next shipment at 5. Okay, so I'll check if this is a valid shipment or not. So 3, I will update my max value to 3 because it's more than minus infinity, and it cannot be one element cannot be a shipment, right, by itself. and it's obviously not more than the maximum, right? So you will go to the 2. So now 2, you already have seen 3 as a maximum. It means that you can cut this one as one shipment, correct? So you will update your count by 1, so your count becomes 3. So this way you can identify the shipments basically, right? So now in this case we found out 3 such shipments, right? When you do it for the second example, what happens? You will see first maximum is 12, then 15, then 18, then 20, and at the 4 you will see that you found out one number where it's not your maximum, right? So 4 is less than 20, so it's not a maximum. It means that you will cut your first partition here, correct? So this one will be your first partition, right? You understood it, right? Why we did that? Because these numbers are increasing order, right? 12, then 15, then 18, then 20. It means that you will find out a number which is lesser than 20, then only you can cut it as a partition, right? Because because last number should be, see, the last parcel is strictly less than the maximum weight among all parcels, right? So then only you will cut it. So this is the way you will cut the first partition, and for the second partition you will have to cut it from here to here. This one will be your second partition. Why? Because 1 is less than your maximum 10. Okay, so this way we will identify these partitions and basically shipments in this case. So this is kind of a greedy approach. Since we are going to go through this given array once, it's just a for loop, so it will be order of n solution. So it will work on a large input cases. Okay, so let's take a look at the Java code, so it will be more clear for you. So max balance shipments is what we are implementing. A weight array is given to us, right? So we'll create couple of variables in the beginning, counter to count the shipments. Maximum weight so far is integer.min value. So maximum weight so far we have seen basically, right, for that shipment, correct? And n is your length of the array. Okay, as I said, we will start iterating through the given weights here. I is equal to 0, start is 0, I is less than in I plus plus. So start is the starting point for any shipment, right? So maximum weight so far is maximum between your maximum weight so far and your current weight. This is important, right? We are using math.max. So you will keep track of the maximum weight you have seen so far, right? So let me remove all these things so I can explain you what it means. So in this second case, you will say maximum weight so far is 12, then here 15, then here 18, then here 20 basically, right? So that's what. And then here you find out something which is less than your maximum weight 4. So you will cut it in one partition, right? So that's what it means. So maximum weight so far, we are keeping track here. And this is the condition where we are checking if we can cut that into one shipment, right? So I should be greater than start, that is one condition, and your current weight I should be less than your maximum weight so far, right? Maximum weight so far, in this case maximum weight so far is 20, so current weight is 4, so it's less than 20, so it means that I can cut this part as a one shipment, right? Okay, so I hope you understanding this. So now once you find the balance shipment, you will increment your count and you will reset your start. So your start will become I plus 1 because you already cut that part, correct? Once you cut that part at 4, right, then your start should start from this index, correct? So that is what exactly we are doing here. And maximum weight so far is equal to integer dot min value. We have to reset that to negative infinity, kind of, right? So that you will keep looping in this for loop and you will keep try to find out the balance shipments this way basically, and at the end you will just return the count and it will give you the maximum balance shipments, right? And so that's it basically. I hope it's clear to you. So before we submit this code, we are going to talk about the algorithmic complexity for this code. So time complexity is going to be order of n, where n is number of weights given in that array. And why? Because of the for loop, right? For loop, we are looping here. It means order of n, and the space complexity for this code is going to be order of 1. This is also called as constant by many people because we did not use any data structures like list, map, hash set, nothing, right, to store anything. It means that this is a constant on space solution. So that's what you can explain. So let's give it a run, make sure it passes the test cases that we have here. So as you can see, the test cases are passing correctly here, and we are identifying the maximum balance shipments correctly. This is a negative test case if you want to take a look. So here you will see that there cannot be any shipment, right? 4 and 4. So maximum is 4, but you cannot, the last one cannot be a shipment because it's also 4, right? So submit this code to the Leetcode, make sure the code gets accepted by it. And as you can see, the code is successfully accepted on 100% on the percentile performance, which is a very good code to solve this coding problem. And this approach, you can identify it as a greedy approach. Okay, so that's how you can approach and solve this problem on Leetcode 3638 maximum balanced shipments. Another quite interesting problem that you want to solve and you want to understand, this is these kind of problems are typical in the online coding interviews as well as in the in-person rounds. So I just wanted to show you with these two different examples so that you can easily understand and follow this logic. And if these examples and whiteboarding session help you understand this problem in an easier and better way, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. Your subscription is very important, it's very valuable, it really helps and supports this channel. Here we create videos to help others in their coding and Java interviews. More than 500 different varieties of solved coding problems are available here. It takes a lots of efforts, creativity and time to come up with these examples and to create these videos. So if you really want to appreciate these efforts, then please subscribe to our channel and give a like for this video, share these videos with all your friends and click on the bell notification icon button right away, so you won't miss any interesting upcoming videos from our channel. The important playlist for you on this channel includes graphs, matrices, binary search trees, binary trees, different data structure playlists such as stacks, queues, priority queues, min heap, max heap, dynamic programming, recursion, memoization, how to use and apply BFS and DFS on graphs, trees and matrices. So do check out those problems. They will definitely give you a good preparation for your interview rounds and will help you learn more techniques of problem solving and Java programming as well. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep trying different approaches of solving problems that will improve on your programming skills and will also help you in your interviews. And thanks for watching this video and have a great day ahead.